Professor, can we start now?
Yeah, sure.
Okay, but I will share about the rules for the student first. May I share the share screen in Zoom?
Yeah, sure.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, the Honorable Professor Suleman. Good afternoon, and all audiences and students attending this lecture. We are very happy now because among us, Professor Suleman would like share the experience and his expertise about application of GIS, Geographic Information System, methods in epidemiological studies. Before we get started, let me to read the rule for participant. Please turn on your camera. Hello student, please turn on your camera and turn off your microphone, and please change your name with the format name underscore institution. And number 3, please behave appropriately during the guest lecture, and you can freely ask by chat menu, or you can ask direct open your microphone and camera. And do not forget subscribe the YouTube channel, and do not leave the Zoom because there will be a link for certificate issuance, and it is active for only 60 minutes. And then it is the curriculum vitae of our Professor Suleman. He is attending in this Zoom. He is from, oh, sorry, because the affiliation is still in the previous affiliation. Now he is in Norwegian University. I'm so sorry. For the education background, the PhD in biomedical informatics, Taipei Medical University, and health informatics from Islamabad, and Doctor of Pharmacy from Pakistan. And for the research project about spatial and temporal distribution of chronic disease in health region, it's very related with our discussion today, and also epidemiological investigation of COVID-19 pandemic. And also in publication, he also published in the topic of Hajj in the time of COVID-19, investigating spatiotemporal distribution, the impact of different surgical procedure, and meteorological influence on dengue transmission. And without further ado, we would like to invite Professor Suleman to give the lecture, and the screen is yours.
Thank you, Professor Lukman, for this nice introduction. So for today, we will talk about the applications of GIS methods in epidemiological studies. So GIS, basically, it's a powerful tool. When it was invented, when it was started, it was not basically designed for epidemiological or for health sciences. The main reason behind it was basically, all the things basically what have been made in the history of mankind, they basically focus on the safety and security. So its initiation was started for war purposes, for security purposes, for to check the movement of the people earlier on. But then once something is there, and then they see how we can apply it further. So that is the reason once it was fully available, then it was applied in political sciences, in geography and security, military, and then ultimately it came to health sciences, or you can say epidemiology as well. And it is it's not something very new. Before the start of computer, it was done manually, like on the papers, and at the time when the cartography was done on the papers and on the manual. So first time it was used in England, we will see later on. So that was basically the starting point of use of kind of GIS or medical geography in the health sciences. So we will see that in coming slides. Okay, so a bit of backdrop or the background. So the tradition of GIS analysis or geographic analysis that starts back to 18th century. So when the maps depicting the rates in various countries first appeared to describe the spread and likely cause of the infectious disease epidemics like yellow fever and cholera. So cholera was basically, and that was the first one. It was done in London in 1854 by a medical doctor. He used geography for mapping the deaths caused by cholera, and so we will see about that. So geographic variations in disease were described and analyzed in terms of the demographics, environmental factors, behavioral variables, socioeconomic conditions, genetic, and other risk factors like infectious risk factors. So they were explored and explained by using spatial epidemiology. So the advances in GIS, along with statistical techniques and the availability of high resolution and geographically referenced health information. By geographically referenced, we mean like we can locate the exact position, like where the case is, where that particular health event happened. So that is what we mean by geographically referenced or geolocated. And the environmental quality data. So these things they open new avenues that were not imaginable before for investigating environmental as well as other local geographic disease variations. Our diseases are varying in different parts of the, for example, one district or one country or globally. As recently we could see from COVID. So there were many different tools to show the spread of COVID. There were some, showing just tables with the deaths and cases and recoveries. And no, it is still moving on. But those one with the maps and showing the dynamic variation in the cases and spread from one location to another location, they were really attractive. So that we can see in the recent world, it was a classical example of US GIS in health sciences. So before going into GIS, so we need to understand what is information system, and then we will know, okay, what is geographical information system. So information, what is information? It is nothing but just it is summarization of the data, like getting the data, summarizing it, organizing it so that we can get some sense out of it. So then the data, it tells us a picture, it gives some understanding. So that becomes information. So technically, the data these are the raw facts and figures, and once processed in the form of summaries or tables or totals or figures or graphs, so that makes information, that makes it easier for us to understand and use it. And what is information system? Information system is that system which basically helps to acquire, access the data, analyze it, process it, and give us output in the form of information. So that is useful for us, that is understandable for us. So this is a formal technical organizational system that is basically helping to collect and process and store and distribute the information. So information systems are generally composed of four things. So there are tasks at hand, there are people who are handling that, and there are roles or structures, and the technology, which is basically the backbone of the information systems. So these are four components of any information system. So that depend, like it is a hospital information, it's a geographical information system, it's a business information system. So any information system in any sectors, these four things will remain same, but who are the users, who are the people will get benefit from that will keep on changing. But these things, the general description of these four roles will remain the same. So once we know what is information and what is information, the next comes what is GIS or geographical information system. So again, that it is nothing new. The only thing which is adding in this one is that is geography or geolocation, georeferencing. So it is a computer system that is helping to capture, store, and check and display the data to the positions on Earth surface. Positions on Earth surface, what does it mean is location, georeference. Like we know we can locate it exactly where that incident happened, where that case happened, where that particular event happened. So the data is basically geographically referenced, which we are going to use in geographical information system. So by relating seemingly unrelated data, GIS helps individuals and organizations better understand the spatial patterns and relationship. Now we are talking about general things. If we are talking about a particular health event, for example, COVID case or a cancer case, so we will know in a particular country at a particular location where there is more risk. What are the environmental factors? What are the socioeconomic conditions? What are the behavioral things in that particular area, that that particular disease, that particular event is happening? Like it depends, like in which way you want to use it for election purpose, for political purposes, for health purposes, or for example, you just want to open a new business. So you would like to understand where are the more customers. So GIS has that capacity, all those powerful tools to help us analyze the situation and then help us to determine or target the potential location for future. For example, we want to build a pharmacy or we want to build a hospital. So we want to understand the dynamics in that region. And GIS will really give us a very beautiful and easily understandable information in the form of visualized maps. So GIS, it's a crucial part of spatial data infrastructures as defined by White House. It is the technology, the policies, standards, and human resources, and the related activities which are important to acquire, process, distribute, use, maintain, and preserve spatial data. So GIS can use any information that includes location. That is one thing, like location, which differentiates it, which makes it clearly distinguishable from any other data or any other information system, because it has a location component. So the location can be expressed in many ways. For example, generally we know the latitude and longitude when we talk about countries or the bigger cities. Or when we want to go to narrow details or minute detail, then we know exactly the zip codes or addresses or the street names. So there are different types of information that can be compared using GIS. So this includes data about the people, the population, income, or the education level, and then exactly the location. So the information could be regarding the landscapes, such as where a particular stream or where particular stadium or what kind of vegetation, what kind of soil is located in that region. How we would know, like Indonesia has a lot of islands. How we would know that uh, countries in Africa, they have a lot of sand, they are not that green. So we know because of the latitude and longitude and those locations and those features which are located at those places. And we are, if we talk about the business thing, then we know, okay, where are the sites of factories, where are the farms, where are the schools or universities, right? And then what is the most suitable place to build a drainage system or a road or electric power line? What are those suitable locations? So it has diverse and many different applications in any walk of life. So with GIS, we are able to compare the locations of different things. So we have the capacity to discover how they are relating to each other. So the one thing which I would like to mention here is the first law of geography is that everything is related to everything in the world. But the things which are close to each other are more related than to the things which are far from away. So this is very important. That is why the component of location becomes more significant. So the things which are related to each other, they are located close to each other. So with the GIS map, we can include the sites that produce pollution, such as factories, and then the sites that are sensitive to the pollution, such as wetlands and river. So we would know, okay, if at a particular river or at a particular stream, the fish are dying. So we would have the capacity to know, okay, like what is the reason behind those death? Maybe there is some pollutant or some chemical coming in. That is maybe a factory which is located in the nearby and that is draining its waste into that river or that stream. How we would know that? That is power of GIS. So map helps people determine where the water supplies are most at the risk. This is a pictorial representation of how GIS works. So basically, as you can see on the upside, that is Earth. And the data is coming with the latitude and longitude. You can see those lines on the globe. These are basically hypothetical lines. They are developed to understand the location. So we are getting georeference or geolocated data. That is the input uh, which we get into our GIS system. So data impact input in the form of, so we capture and digitalize. So it could be any data basically. The next things are same. So the data is always stored in a database management system. So for the data analysis, different models, different statistical tools are used, and for sharing, there are data warehousing, CDs, DVDs, and WebGIS. These are data sharing tools. And then what is the data output? It would be in the form of a map display or visualization, or it would be a multimedia representative. In a video, dynamic maps. So the only thing which makes it different, the data is coming with the geolocated component. So next, we talk about geography and medicine. So apparently they seem two different things, but ultimately in this global world, everything is linked. So we want to contain infectious diseases in a particular region. So for example, we know the countries which are, so for example, the countries which are located in Africa, they have more cases of malaria. And those countries which are located in tropics and subtropics, they have uh, dengue and other vector-borne diseases. So what is the reason that those areas are having that type of diseases? The reason is the climate and the landscape and the location is more favorable for those vectors. For example, mosquitoes, which can carry those viruses, right, or plasmodiums. So once we know that, then we know, okay, we need to target those vectors. We need to stop them to spread in the vicinity. So that is why geography and medicine, they are interlinked. So they help to control the infectious diseases, because which is very important, and disease control that requires understanding. So for understanding, we need to know the location. We need to know the local dynamics, and geography provides the intelligence. So that gives to that information which is useful for protecting those areas. And location can influence health. For example, the countries which are cold, there are different kind of viruses or microbe. Countries which are hot, where there are different kind of mosquitoes or other insects which can transmit the diseases. That is why location has very important influence in health. So the start, as I mentioned in the beginning of the presentation, start of geography in the medicine, it happened in 1854 when Dr. John Snow, he did mapping for cholera. So he mapped the people who died because of cholera, and then he was able to find out there is something which is linked to a particular pump. So that is actually a classical example. And whenever we study about the role of GIS or geography or geography in medicine, so that is kind of that was the start of use of geography in the health sciences. And the spatial analysis, it helps in solving the medical problems. No, that is the pump which they have still preserved in London. As you can see in the background, there is name John Snow. The name of that area they have named at that. So all the people who were taking the water from this pump are located nearby. All the deaths happened around that area. The reason was the water in this pump was contaminated with the cholera. So that basically spread, and then the people died because of that. And that is the map which John Snow created manually back in 1854. So it was in London, and he, as you can see, these are different stacks of the deaths. So here is location of the pump, and most of the deaths are happening here. But as we go away from that location, the number of deaths is decreasing. So what it shows is there was something in that pump that should be resolved, so that then the people will definitely they would not die, or they would not catch cholera. And next, we go towards GIS applications in epidemiology. So there are 6 major applications. So first one is data visualization and exploration. So we will go in detail, one by one for different applications out of these. Then data integration, GIS can be used for integration of the epidemiological data, for monitoring epidemiological data, and then geostatistical modeling, spatial epidemiological inquiries, and data sharing and web services. So there are three different types of spatial epidemiological inquiries. One is disease mapping, which is very common, and we recently saw in for COVID as well. So disease mapping is very common type of spatial epidemiological inquiry. And then there are geographic correlation studies. So geographic correlation studies, they basically tell how the things are correlated in space and time to each other. And then the disease clusters are surveillance. So the statistical model which are used to conduct such research are complicated. So statisticians should always conduct data analysis and interpretation. When we talk about involving the location component, that is not clustering or correlation of the normal data which is out of the geographic component. So this involves 3-dimensional analysis. So the spread of disease mappings mistakes has sometimes resulted in inefficient decision making, the adoption of ineffective health policies, and a negative impact on scientific knowledge advancement. So once we are not able to map the things properly or visualize the things properly, it means we are the decision which we will make on the basis of that analysis, on the basis of those maps, that will be incomplete. So when it is incomplete, so the decision would be inefficient. So the strategy will be made that will be ineffective, and that definitely will be that will lead to the negative impact of the scientific knowledge. So disease maps are visual representation of complex geographic data that provides a fast summary of the data. For example, we know there are, as if I talk about Saudi Arabia, there are 13 regions. So if we just talk about numbers, then we know, okay, there is more people living in Riyadh region, so there are more cases there. That is well understood. But it is possible that there are more people living, and that is the reason there are more cases. But when we add the component of population, so there is another location, there are less cases, but there is also less population. But when we divide according to that population, maybe the incidence is more there. So incidence mapping, basically, that will help us give more true or more clear picture. So disease maps are mostly used for explanation or ex ex explanation, but they can also be used to scan high-risk areas to find out those hot spots, those target areas where there are like specific risk factors which lead to those uh, higher burden of disease or higher number of cases in that region, and it improves policy and resource allocation in certain areas. The second type of study is geographical correlation studies. So correlation studies, they help to investigate the effect of geographical determinants on spatially varied health outcomes. So how the things are different in different part of a location. So environmental characteristics, for example, quality of surroundings, or socioeconomic and demographic statistics, what kind of people are living there, what is the income, and even the lifestyle choices, for example, what kind of nutrition or food the people have. All of uh, all of these factors in different population groups under study, so they can be measured on an ecological scale. So this will give actually very uh, detailed and interesting information about the population which is dispersed at that location. So this method has the advantage of being able to use data that is already available from multiple surveying resources. Now, good thing about advancement of the sciences is that now all the countries basically they are at a particular after a regular interval they are collecting new data, and they are they are making it available for public use. So it is easier to get it and compare it and then see the difference which has happened from previous year till the recent years. Next are the clusters, or that is the third type. So clusters of disease are the special grouping of epidemics that are close together, and definitely as I mentioned earlier in the first law of geography, the things which are located closer, they are more related to each other. The things which are apart from each other, which are far from each other, they are less related. But yes, they are related. Although the phrase isn't well defined, it is understood to mean that an excess of cases above some background rate, bounded in time and space. This is the definition of a disease cluster. So that would be excess or above normal uh, aggregation of the cases or the events at that place. Even though clustering is not the most precise method for spatial analysis, it has been very effective for health surveillance as well as monitoring. Next are the spatial analytical techniques. To form the public health policies, presentation and identification of spatial patterns are very critical. So these approaches are discussed uh, and confined to those they entail a visual exploratory data analysis. So what are those techniques for spatial analytical analysis? There are point patterns, there are line patterns, there are area patterns, and then there are surface or contour patterns. They visualize or map the same thing, but it will depend what kind of information or what kind of location we want to represent. So we need to know which technique is more suitable to map or display that data. First one is point patterns. Point patterns, another name for that is also dot maps. These are point patterns. They seek to depict the distribution of health occurrence as data places. So the ability to overlay data locations with other relevant geographic information such as city map or health facility distribution. So it's a powerful general tool. So basically what John Snow did in the map I show about cholera, he determined the sources of cholera spread in London, which is a famous example of point pattern analysis in epidemiology. So he identified the source of contamination as a water pump. On the basis of that point pattern map, he was able to identify like where is the cause, where is the reason that that thing is spreading. So using dots indicating the cholera deaths in London's Soho neighborhood. So that was a classical example of point pattern maps. So the use of dynamic graphics, which may be more easily integrated within GIS software, is an appealing alternative to point pattern. So dot map can be linked to a histogram of case occurring during this method. By selecting the higher tail of histogram, the relevant instances on the map are immediately highlighted, allowing for eventual definition of the illness hotspots. So it is basically more robust and has more capacity to visualize the data. So cases picked in one section of the map can be categorized into the histogram in another way. Each data location's temporal case occurrence could also be displayed. So it gives variety of different tools to display or visualize the data. The next are the line patterns. So there's the vectors, which are also known as lines. These are geographical resources that help with disease diffusion, like how it is spreading in the community. And patient or healthcare facility flow maps. So lines show the presence of flu or contagion between two subregions that may or may not be contagious in their most basic form. So arrows with the width proportional to the volume of the flow between areas are useful tool for assessing the different locales healthcare needs. Francois and Schneider, they created a flow map, which is a interactive graphic computer software that generates a variety of origin destination maps to basically visualize or show how the a particular contagion or how a particular uh, vector is spreading in the community. So line pattern is frequently used to characterize the spread of various epidemics, such as international transmission of AIDS. So the inclusion of a model like flow map in GIS software appears to improve the application of line pattern analysis in the public health sciences. The third one is area pattern. So the initial step in data analysis to describe the data sets are accessible using tables or one-dimensional visualization like the histograms. The most obvious choice for spatial analysis is data in on maps. So once we have the location component or georeferencing, then we have the ability to visualize it, to show it in the form of a map. With the variable of interest separated into classes or categories and are plotted using a color or a cross inside each geographic unit, which is generally called as the chloropleth map, which is most commonly used method of depicting the disease cases or disease mortality. So predefined cases of health occurrences or the mean and standard deviation of their distribution are used in the most frequent maps. Administrative boundaries such as counties, municipalities, health districts, and so on are commonly used to represent maps where the data is collected. And what are the measures which are shown? That includes incidence rates, mortality rates, or the standardized mortality ratio, the or important variable in area pattern. So that they basically show the distribution in whole area in the aggregated form. The fourth category is surface or contour patterns. So they are most useful when the data is continuous in nature. So data of epidemiological importance frequently appears as spatial information. The previously stated analytical methodologies necessitate the pooling of the data in administrative areas with well-defined geographical borders and depiction of the spatial access using maps defined to those areas. The map frequently fail to depict health issues at the neighborhood or sub-county level. So when we want to show the spread in the neighborhood or sub-county, then we need contour patterns. So that kind of shows the continuity of the data. So the epidemiological factors are not always aware of political boundaries. Like for example, COVID doesn't know like it has where is the boundary and it cannot go beyond. So when we want to visualize it, we have no choice except to use these contour patterns. So surface and contour pattern analysis, this represents the distribution of health event. It provides an alternative to administrative areas for mapping. This special analytical technique has the advantage of treating the variable under examination as a continuous process across the entire region. This is the major difference behind the previous three patterns. So surface and contour patterns, they basically help to show the continuous process across the entire region. So an health event is assumed to be a continuous process. It is observed at a series of geographic sites known as sampling points and surface and contour analysis. The contour maps, which is also called isoline or isopleth, is a plane projection of the defined surface that corresponds to the constant z values. So next, what are the challenges with this use of GIS in health sciences or like general? So data availability and quality, that is the biggest challenge. So gathering the data, it should be routine, reliable, and publicly available because spatial epidemiology is entirely focused on data analysis and its visual representation. So when the data is not available or it is not of high quality, then we cannot really use or get the most out of it. So these procedures can be relatively and readily enhanced with the development of specialized and accurate health equipment and global information networks. With the correct tools and techniques, compiling and standardization of the data may be done more quickly and more effectively. And then data protection and confidentiality, that is another big challenge because we are displaying the information in the form of a map. So if the data is not properly masked or if it is not protected, so it is possible to get to that patient or get to that case where that's certain. So that is kind of intrusion in the confidentiality of the patient. So individual human rights law is gaining traction in the world, particularly in respect to the secrecy of personal health data and consent to use it in medical investigation. Successful epidemiological research necessitates to use of safe and secure data. That is a very delicate issue. So, and the assessment and mapping exposure, the quality of exposure data or stated accuracy of epidemic spatial reach is extremely crucial in spatial epidemiology, and it is overlooked as an analytical flaw. Next are the study design for generally there are two study design which involve GIS in epidemiology. That is, one is cross-sectional ecological studies, which are mostly descriptive in nature. And then the second is case control crossover acquired studies of the environmental risk factors that are more analytical in nature. So cross-sectional ecological studies, the unit of analysis grouped by administrative unit. That could be a nation. For example, we talk about countries, like for example, some global analysis being done. So countries or those nations will be taken as the administrative unit, or an autonomous region, zip code, or census tract, or districts when we talk about a particular country, so, or the health facility, school, or the other organization unit. Then the spatial dependence or the clustering, that must be announced for using smoothing technique, for example, spatial regression or multi-level regression. And one problem with these is ecological fallacy. What it means is we cannot generalize something which is appearing at a country and then we say, okay, that individual is also having the same thing. For example, there are many people in Pakistan who love cricket. It is a cricket loving nation. But then we can't say, pick a particular person and say, okay, because this country is a cricket loving nation, so this person also loves cricket. So that is a flaw in this thing. And generalization of hypothesis becomes difficult in cross-sectional ecological studies. The next is case control crossover or cohort studies of environmental risk factors. So GIS helps to estimate the measures of access, for example, distance to the facility or other local estimates which are derived from spatial surfaces. And geocoding of addresses linked to sensor level, socioeconomic, socio-demographic, and environmental variables, for example, air pollution or water quality. So the data for spatial analysis, like from where we can acquire that data. The point data and area data are two most common types of spatial data, like knowing exactly latitude and longitude of an event, or knowing the area, like how many square kilometers, how many meters where a particular area, a house or a county is located. So each piece of health information, for example, population, environmental exposure, mortality or morbidity, they can be linked to precise spatial location, such as a house, street address, or an area which can be specified as a postcode, ward, local authority, province, or county. So this is where we need to be more concerned. We can't give the details which can exactly help to locate the person, but as a group. So a public health professional may also encounter geographic data in the form of continuous surface, such as a statistical representation of pollutants interpolated from fixed point characteristics. So this is done basically to help protect the privacy of the individuals. Disease clustering. So disease clustering is one of the fields of spatial epidemiology that involves assessing disease accumulation on a local or global scale. There are two forms of clustering. One is general and one is specified clustering. The assessment of global spatial autocorrelation, in which the location of clusters is not explored, is like general clustering, which entails the investigation of overall clustering tendency of the illness incidence. The second sort of clustering inquiry implies disease clustering methods that are aimed to investigate the exact location of the clusters. So once we know the exact location of the clusters, we can further explore those local variable environmental factors or socio-demographic factors that could lead to that cluster or high intensity of the disease in that region. So there are more methods for detecting clusters in the point format data than there are for aerial format data, and they are usually categorized into three. One is global, localized, or focused. So assess clustering around a putative curve. So there are a variety of tests that can be used to evaluate different types of clusters in the point format data. Disease mapping. So data visualization not only pique the viewer's curiosity and draw them in, but it can also lead to unexpected discovery. By pique, it means like giving a negative impact. So they basically discourage them. So even though plots of data and other graphical display are among the most basic tools for analysis, in general, visualizing special data for a special analysis usually means utilizing a map. So disease mapping is a subfield of geographical epidemiology that addresses the requirement of reliable disease morbidity and mortality maps. Point data is displayed using a dot density map, whereas aerial data is displayed using a choropleth map, like where the whole region is kind of, uh, given a particular color or a scale of color to display. And continuous surface data is displayed using a contour or isopleth map. When we study about point data and choropleth and continuous data, we know what kind of technique is more useful to display the data. So the use of mapping in the medical setting has advanced so quickly in recent decades that it is now widely accepted as a standard technique for analyzing public health data. The next is ecological analysis. Ecological analysis refers to a study of relationships between disease incidence and the variables of interest, which is the social and environmental covariates. So these variables are specified on aggregated groups of individual rather than on individual. The reason for concentrating on group comparison rather than individual comparison is that personal level data on the giant distribution of two or more variables within each group is frequently lacking. So there is no basically choice to do individual analysis in the ecological analysis because data is not available for each individual. So this can be crucial dependent on scale. The best scale is a compromise between making groups large enough to have consistent rate estimates while keeping them small enough to be homogeneous in terms of socioeconomic and other essential features. So it is a trade-off. So you have to make a fair distribution, not very big region, not very small region, so that some details are masked or some details are overrepresented. Geographical epidemiology is the study of spatial patterns of disease morbidity and morbidity as a part of descriptive epidemiological investigations in order to formulate hypotheses regarding disease etiology. So there are different disciplines of spatial epidemiology. Which reflect the various needs of public health specialists and epidemiologists in the assessment of disease etiology. Illness mapping, disease clustering, and ecological analysis are most common approaches of spatial epidemiology. We have gone through basically disease mapping, disease clustering, and uh, and ecological analysis in the previous slides. Okay, next comes the GIS and epidemiology. So particularly it is defined as a software system for automatic capture, storage, retrieval, analysis, and display of the data. So they do GIS approaches use modern epidemiology, increasingly incorporate this spatial perspective, which is the location component, and the research design and models. Then distance estimation, record linking, and data integration, which is disease mapping and spatial-temporal clustering. Which this is something which is done very often in all the epidemiological analysis, knowing the spatial component and then what are the spatio-temporal clusters. And the small area estimation and Bayesian application to disease mapping. Smoothing. Mapping illness, mortality, or morbidity, particularly in smaller geographic areas or when the condition is relatively infrequent, can result in an issue of small numbers which are which result in unstable rates. So peaking wide areas may result in more stable rates. Mere mapping of the rough axis unappealing, but it still results in abrupt shifts or geographical boundaries. So then to overcome this issue, smoothing is the technique which helps to overcome this issue. Spatial autocorrelation. Spatial autocorrelation is different than the normal correlation or autocorrelation. It is caused by lack of independence of data from neighboring places. Correlation or dependence refer to the fact that rates from geographically close locations are more closely associated. Again, it follows the first law of geography. Then rates from the distance areas. Suicide rates in nearby locations, for example, are likely to be like those in remote areas. This is because suicide behavior may be triggered by comparable underlying social, economic, or cultural features in those locations. There are different statistics which are used to measure the spatial autocorrelation. For example, I statistics, which is produced by Moran, and there's G statistic, which is Giri's C statistic. These are most commonly used spatial autocorrelation statistics for finding global clustering in continuous aerial data. Then is the spatial regression. These correlation and regression, these are not exactly the same as for the data which is not geographically linked, because this involves a third dimensional data. So in most ecological analysis, we deploy a regression model to predict suicide rate in certain areas using other characteristic variables such as poverty or social cohesion. In such scenarios, we divide the research into several non-overlapping administratively defined areas and simulate the number of cases within each area. If the risk is small, for example, suicide mortality, the Poisson distribution can be used to approximate the binomial distribution. Then spatial analysis in epidemiology. So data preparation these are different steps basically which are used for spatial analysis. The first step is always data preparation. GIS and statistical analysis measure indices. In epidemiology, they are incidence, prevalence, relative risk, or odds ratio. Then data integration into polygons, standardization, environmental data, and integration within the GIS. Then spatial visualization of the cases or prevalence, incidence, odds ratio, or regression residual. Then spatial dependencies analysis, which is point pattern analysis that helps to show position, trend, structure, centrality, spatial model. Then cluster detection, finding out the hotspots. Then space-time analysis, finding out the clusters at a particular time and place, which includes both the components of space and time. So that include time analysis, visualization, moving average index cases, and then space-time local cluster detection, and then modeling the spread, finding the diffusion model in space and time, finding characteristics of the spread. So these are the steps which are always involved in spatial analysis and epidemiology. Data preparation, always very important. So once you have your data prepared and integrated, then everything becomes, if there is any error in this step, then whatever you do subsequently, that would be always having some mistakes or some flaws. So spatial data in epidemiology, epidemiological data, which is at individual or aggregated level with the place and time of the patient from public or private administrations, such as health ministry or hospital or insurance companies. And the environmental data, which is possible risk factors, air, soil, water pollution, climate data, for example, temperature, humidity, rainfall, all those variables, economic activities or agricultural activities, and then the urban environment. It's what is the land use? There are forests, water bodies, green areas. How is the area being used by the people in that scenario? So these are different kind of data for which we can check the impact on the different diseases or health events. For example, here in my project here, we are going to check the impact of climate variations or green areas on the spread of COVID, or how are the differences in COVID cases in different locations here in Oslo. So field surveys, they are also another kind of data that can be used in epidemiology, which is observation inventory survey. These are regularly conducted. And then interpretation of remote sensing data, which is aerial photography or satellite images. Well, there are different softwares which can be used for this kind of analysis. Most common is ASRIS or GIS data. It is very powerful tool and relatively having more tools. Then quantum GIS, QGIS, SAT scan for spatial, temporal, scan statistics, GRASS, and Autodesk. So the potential of GIS currently underutilized. So it has great potential in epidemiological research, communicable disease control and health services, planning and optimization. That is this is where it is really needed for planning and optimization of health services. Then of course any tool or any service which we have is not always self-sufficient. It has certain limitations. So there are certain communication gaps between epidemiology and spatial professionals. So there is need to bridge this gap to make them more understandable, more close to each other. So this requires uniform data standards. For example, addresses regarding 1 by 32 Main Street or Unit 132 Main Street. These two things, same thing, but different ways of expression. Unit recorded data access, consistent, meaningful area units. So for different purposes, there are different ways of explaining the areas. So enable consistency and comparisons to avoid those limitations. And then always there are privacy issues because we are visualizing the locations, or we are showing the disease cases or spatial aggregation. In summary, so GIS provides spatial dimension to epidemiological research, which is visualization and modeling of the epidemiological health data. It can be used for many public health applications and services, for example, efficient allocation of healthcare resources, equity and accessibility to health services, and then more advanced form is Internet GIS or Web GIS that can provide the public health information in real time. For example, as we saw for COVID-19, even there are certain websites which are giving the real-time information as the cases is happening, so you can see how the situation is evolving. And it is not just for health sciences. It is done, for example, for rain, climate, weather predictions. So this can be done for evaluation, CN support system, and emergency response. And with this, we are here to end the presentation. With this, I would say thank you, Tushantak and Nushk, Norwegian. And now the floor is open for the questions.
Okay, thank you, Professor Suleman, for your interesting lecture.
Thank you.
I would like to invite to students to open the discussion with Professor Suleman. You can write down the question in the chat, or open the mic. Is there any question, student? Or from me first, Professor?
Yeah.
That you said in the presentation, we often see the publication or study using GIS that discuss communicable disease related with the environment factors like climate, vegetation, river. My question is it possible if this GIS used for mapping disease that is not related with environment? For example, non-communicable disease.
It is possible. It is possible. But the thing is, if we are going to relate it to something for which it is not related, then it is not useful. So then it is more useful to use mapping with the socio-demographic conditions, for example, socio-economic status. So in that, it will give more information. So if for example, if for a particular disease, temperature is not going to have any impact. So if we want to show the effect of temperature, then that definitely it doesn't give any impact. But maybe, for example, for non-communicable diseases, the living conditions, socioeconomic conditions, educational level, those are more important in those regions. So that is more useful to visualize those socio-demographic characteristics with the incidence of those diseases, rather than the climatic or environmental risk factors.
Okay. So in non-communicable disease, we cannot know about the most relationship between risk factor and non-communicable disease. You mean that, or?
I mean, if we know for example, the environmental risk factors doesn't have any impact, so there is no. Of course, we can do, but once we know it doesn't have any impact, then it is not useful to do that kind of analysis. So in that ecological analysis, it is better to use socio-demographic and other factors which have real impact.
Okay, got it. So students, any question from you? Okay, one student open the camera. Mamlatul, would you ask the question?
You need to unmute.
Yes, Mr. Lukman.
Okay.
Ask a question to Professor Suleman. So, Assalamualaikum, Prof. I'm Mamla, and I would like to ask about the disease mapping. So, as what Professor Suleman said, that disease mapping can also used to for explanation and also improve policy or other rules to control the problem. And what I want to ask is, when we want to make a disease map to show the magnitude of the whole problem to the stakeholder with not health or medical background. So please give us any tips and tricks to make a good disease map so that the stakeholder that didn't have any medical or health background can understand the disease map that we make. Thank you, Prof.
Okay, so for that, the best thing is to use a choropleth mapping. For example, there are more administrative boundaries, maybe there are 12 or 20, so you can divide that into, for example, certain categories, 4 or 5 categories, and then you can give a scale like where there are more cases. So that will give a more colorful representation, and the person who is not medical background, he will know, okay, that is the reason where there is something where, for example, we need to have a more health intervention, or we need to develop a hospital because the cases are more happening. So choropleth map is more useful to visualize or show the impact in that region. So for non-medical background people, that is because it is visually more attractive. So that is a useful thing for that.
Any further discussion, Mamlatul?
And I want to ask one again, Prof. And in the mapping, how about the color? Is there any color that can that can be used as an apa kayak patokan begitu, Pak Lukman? Mungkin Pak Lukman bisa menyampaikan.
Yeah, the template of the color should be.
There are templates already available. For example, we always know that red is more dangerous and green is like more peaceful. So there are color ramps available. So for example, for non-medical background people, you want to say something which is more risky or more important, you can use that color ramp, which is starting from dark green to dark red. So when your map is showing different administrative areas with different colors, and you use it from green to higher intensity red, that is really attractive and useful.
Okay.
I get it. Thank you, Prof.
Welcome.
Okay. Any other question from the student? Any other question? If there is no question, would you please give the closing statement, Professor? Because sometimes students will be afraid if they have to study with the map, because so hard to make a map with the software, with the different with only statistical result without the map. Would you please give us the
okay
closing
so
statement?
Yeah, okay. So generally what happens is everyone has different interest and different background. Some people, when they see the numbers, it is easier for them to understand. So for some people, when they read a text, for them, it is easier to understand the thing. For some people, it is, they don't want to use their brain that much. And they, for example, they see something either moving or static in the form of a map that gives very obvious and very easy to understand information. So maps are useful for that. For example, specifically those people who want to maybe want to work in bureaucracy in the long run. So these mapping techniques, they are very useful and attractive to understand the conditions in that uh, location or that phase. And another thing which I would say that is more general, when you don't ask question, there are two meanings. One is like you understood everything. The second is you don't understand anything. So now you can decide in which category you are. So never you should be afraid to ask a question. That will open a new avenues of learning, and it will definitely give you more chance to ask, understand, and even self-realization. So never be afraid to ask question. It is very important being a student and to ask a question. If you don't ask question, it means there is a big gap.
Okay, thank you once again, Professor Suleman, for your time, for your willingness to give the experience, your expertise to our student. And once again, give big applause for Professor Suleman. And to all students, please open the camera and we will take a picture together. Okay, we will start from screen number 1. I count 1, 2, 3. And screen number 2. Okay. Once again, thank you, Professor Suleman. Hope in the future we can make a collaboration in the research or publication or in the guest lecture
Inshallah.
again.
Inshallah.
Okay. And would you please share the material to me
Yeah, sure.
by email?
Yeah, I will.
Okay. Okay. Thank you, Professor
Thank
Suleman.
you. Thank you. Bye-bye.
Goodbye.
Bye-bye.
For you guys, I would like to share the certificate. If you check again the previous the previous guest lecture was aimed with SKP SKP credit professional from me SKP. So today's guest lecture and the previous guest lecture, your certificate will aimed with professional credit number from Indonesian Public Health Association or IACMI. Okay, you can click the link. Every recapitulation of the data that you submit to me, I always check. Yeah, I always check the previous one is if in the form they ask what can be summarized from this lecture, you say only no, sir, enough, good. I know, because I always check one name by name. So please, when you are filling form in this link, sure that you are good in filling the form. The second example, there is student that the form, what can be summarized? See, he filling with cacar monyet. What happened? We never discussed with cacar monyet. with monkeypox. Yeah, we only discuss with Professor Henry is field epidemiology. We can study in low cost research, and the second is Professor Usman, how to publish in index journal. The third is with Budina about artificial intelligence, and the fourth is today GIS. So once again, please be correct, please be ethics. Yeah, I know one by one who fill the form to get the certificate. Okay, you can fill the form until 5 p.m. Okay, thank you all and have a weekend. Have a nice weekend. Assalamualaikum warahmatullahi wabarakatuh.